Hello, everybody. I hope you are good. Can you all hear me and see the stream?
I can hear you.
Okay. Um, all right. So let's start with the work. And we only have limited time. So my idea is to at least do one question at each chapter. And then if you have any questions regarding other different types of questions or uh, other variety of questions that you think they can ask, please ask me and then we can discuss that as well. But as we are going along and we're doing a few questions, I'll explain the necessary information, everything that you need for other type of questions. So you are writing about 12.5 up until 14.8. So starting this beginning work, you already written about this, I think, class test and that other big test and so forth. So I think the most of the meat or most of the test, I think, will be about chapter 14 because there's a lot of questions that they can ask, Lagrange stuff and the chain rule and limits and everything like that. But let's at least start with chapter 12.5 and do a question there, and then we carry on with each one. Right. Before we start with some questions, is there any questions from your side? Anything that you wondering about or so? Nothing. All right. So let's have a look at the question here, where they ask us anything about the equation of a straight line and the equation of a plane. So there's two, we need both of them. So here they ask us the following. They say, find parametric equations for the line through the point that is parallel to that plane and perpendicular to the other line. So let's just see. So I think this is a good question because it covers basically everything that you need to know of 12.5. So let's just go through it again. Find a parametric equations for the line through the point. So there's some sort of point. Here's a point. It is 0, 1, and 2. We should find the equation of the parametric equation for the line that goes through that point that is parallel to the plane. So there's some sort of plane, and it's parallel to this plane, wherever that plane is, and perpendicular to the line. So it needs to be perpendicular to another line. So there's another line like this. And that line's equation is 1 plus t, 1 minus t, and 2t. All right, so let's just get back to the equation of a line. The equation of a line, we need a point, which we have, luckily. So that's fixed. And we need the direction, which currently we still don't have. But we know it must be perpendicular to the orange line. So that we know. And it must be parallel to this plane as well. Now, what we can do is we can say, all right, if it's parallel to this plane, I know at least what this plane's normal vector is. This plane's normal vector is 1, 1, and 1. And it's parallel to that. So I know now that this vector here, this direction here, and that direction, it is both of them are perpendicular to this line. Which means if I cross product the orange one and the blue one, I will find the normal, or let's say the direction of this black line. So this orange one, the direction of this orange one is 1, -1, and 2, because it's just that t. So remember, for a straight line, you just need a point, which in this case will be 1, 1, and 0, plus t times the direction, which is 1, -1, and 2. So I just took that direction. So now if I'm going to cross multiply those two with one another, the blue and the orange one, ijk, the normal one is 1, 1, 1, and then 1, -1, 2. Because remember, this line here will be perpendicular to the orange line and perpendicular to the blue line, because this line and this plane, they are parallel, which means the perpendicular part of this plane is also perpendicular to that one. So we have here 2 plus 1, and then we have 2 minus 1. And we have -1 minus 1. So we have 3, -1, -2. And there we have the equation of that line. Let's make it red. So the equation of this red line then is let's just see, is then just RT is the point, which was 0, 1, 2, plus t times 3, -1, -2. So we have here 3t, -t plus 1, and -2t plus 2. And that is the final answer to that line. So this question was actually nice because it asked a few things. We needed to remember about the equation of a line and equation of a plane and everything. I hope the idea made sense of what we should have done, or what you should do if you get a question like this. Now let's just show what I've done here and see how it makes sense. So there is some sort of point, and this point is the point 0, 1, 2, a point there, and there's a plane that says x plus y plus z equals 2. So whatever this line is, it needs to be parallel to that plane and perpendicular to a line that says 1 plus t, 1 minus t, and 2t. So there's just a random line, but it needs to be perpendicular to the line and technically parallel to the plane. So we said it will be 3t minus t plus 1, and then -2t plus 2. And then we can see that line that we are interested in, this one here. Let's just make it red. That red line is indeed parallel to the plane, to the light blue plane, and also perpendicular to that other black line. So we know the answer is then correct. All right. Any questions from your side? No question. All right. So let's carry on to chapter 12.6, and 12.6 is all about that quadratic surfaces. So they always ask a question like that, and it can count like 8 marks or 10 marks. So let's just see how we can draw this. So let's take, for instance, this one here. And they ask us, we need to make use of traces and then find whatever shape this is. Now, it will be good. It will be good if you know all of those six standard formulas that graph of the graphs of quadratic surfaces in your textbook. It will be good if you know all of them. But if you don't know it, you can always just figure it out as you go along. Now, let's just see if you know your work, you will see there's a constant. So it's maybe this one. There's a constant involved. There's not a constant involved. There's not. Here's a constant involved. And here is a constant involved. So it might be one of those. And then I see all of them are squares. So all of them are squares, squares. All of them are squares. 2 must be positive. So if one is on one side, the other 2 must be on the other side. So it doesn't seem like that one. It might be this one here. And it also might be this one here. The only problem is here, if the 1 stands alone, then it's negative that constant. Here, if the 1 stands alone, then it's positive that constant. So something tells me, if I just quickly have a look at it, it might be that hyperboloid of 2 sheets. But if you're not 100% sure, you can also just check it out as you are going along. But I would say in the end, it's this one here because it's positive. That number is positive with that. I'm just going to leave it there. And let's see if that is indeed the case. Oops. It shouldn't be that. Just post it again there. And the one was, let me just get back to the question. It was this one here. All right. So it takes it takes really long to do these questions, but let's see what we can do and how efficient we can get the final value or the final answer. So this time it's in terms of y, not in terms of z, but we shouldn't stress. We do the same thing. So I'm going to first look in the x direction. So I'm going to make xk. So if I make xk, I have the following. Y squared equals 4z squared plus k squared plus 4. Now, I first need to calculate where will stuff happen. Where will maybe a turning point will occur, or just a figure as we have it. What will happen as we are going along in the x direction? And we then equate the constant. We will check where is the constant equals to 0, or perhaps smaller than 0 or greater than 0. But in this place, it will always be positive. K squared plus 4 will always be positive. The lowest value it can be is 4. That's all. So if k is 0, what will happen? We will have y squared equals x squared plus, equals 4z squared plus 4. So we have y squared minus 4z squared, that's 4. And if you have two squares subtracting from one another, then you know it's a hyperbola around which axis? Well, the axis that wins. What do I mean with that? This answer is positive, which means between these two, the y should win. So if I'm looking exactly in the x direction, that is the y-axis and this is the z-axis. Then I will see hyperbolas over or around the y-axis. So it will be hyperbolas around the y-axis. Like this. And then also like this. And as it's getting larger and larger, because that value is just going to get larger and larger. So you can say, well, for k greater than 0 or k smaller than 0. It will be the same thing. It will just enlarge. So you will just see stuff like this. and then that, and so forth. So that's all that we will see. You can figure out what those values are there exactly. The lowest point it can be, that is when z is 0. And when z is 0, when z is 0, then y squared is 4. So it's just at 2 and -2. And that is then for the x direction. Let's have a look now at the y direction. In the y direction, I'm going to make y equals to k. So I will have k squared equals x squared plus 4z squared plus 4. So I will have x squared plus 4z squared. That's equal to k squared minus 4. In other words, if I divide with a 4 throughout, I just have this x squared divided with 4 plus z squared over 1 equals k squared minus 4 over 4. So this constant, just equate that to 0, which in the end will be where k is positive -2. Positive -2. So I know something will happen at at k equals positive or -2. So first of all, I'm going to have a look. When k is positive -2, what will happen? I will have x squared over 4 plus z squared over 1, that's equal to 0. And again, I'm looking in my y direction, right? Exactly in the y direction, which means that is my x, this is my z. And if k is positive or -2, all that I will see is just a point, because the only way that something squared plus something squared can be 0 is if both are 0. So it's just there. I will just see a point. But if k is smaller than 2 but greater than -2, what will we see then? Well, then this part here will unfortunately be smaller than 0, which it can't be. Does not exist. It does not exist. So there's a void if k is between -2 and 2. So if k is smaller than -2 or k is greater than 2, then we have this, but this time it is greater than 0. Which means, what do I see then? Then it's just something squared plus something squared, which is a number. Now remember, if you have something squared plus something squared, it might be a circle if they are in a relationship of 1 to 1. But in this case, they are not. Which one is bigger at the bottom? The x. So you will actually see an ellipse that's a bit wider in the x direction. And as you are going more and more, it will just expand more and more and so forth. Just be like that, and maybe smaller and getting smaller and smaller until we reach that one point. So that's what we will see if we are looking in the y direction. And lastly, we need to look in the z direction. So I'm going to make z k now. So if z is k, we have y squared equals to x squared plus 4k squared plus 4. So again, the constant, equate that to 0 to see if there's critical points. I will see that it will always be k squared plus 1 equal to 0. So this part here will always be greater than 0. Again, almost like the red one. So if k is 0, just to have it as its minimum, then I will have x squared plus 4. Again, we will have y squared minus x squared. That's 4. So which one wins? The y wins. So looking from above, if this is the x-axis and this is the y-axis, looking from above, I will just see hyperbolas around the y-axis, with those values there being -2 and 2, just like this part here. And then if k is greater than 0 or k is smaller than 0, I will see the following: y squared minus x squared equals 4k squared plus 4. So it will just get larger and larger. So it's almost like the red one. So all that we will see is stuff that goes like this, traces that goes like this. Here's the y-axis, and here's the x-axis. So to combine all of these, in my x-axis, which is the red one, I will see hyperbolas going like this. In the y-axis, which is the green one, I will at some point just see a point both sides when k is equal to positive and -2. So when y is equal to positive or -2. Other than that, there will be some sort of void, and then other than that, I will see ellipse. I will see an ellipse, and then from above is also that part there. So that's why I know we can draw it like this. There are 2, there are -2, and then in the end, it will be something like this. And it will not be a cone, but ellipse. Something like that, and something like this. And that is what we will see. And remember, you only get in maybe 1 or 2 marks for that. So that final drawing is not that important. The important stuff is when you are saying what is equal, what family do you see? Hyperbola, straight line, just a point, and stuff like that. All right, any questions? No questions. All right, let's then move to the next chapter, which is 13.1. It's all about the space curves now. So now we don't just work with straight lines, we can work with any weird curve and so forth. So some of the questions that they ask here is the intersection of two figures. And then you need to get the equation. You need to find the vector function that represents the curve of intersection of two surfaces. That's one type of question that they can ask here. And what you always do with this is if you see a circle somewhere, then you need to work with r cos t and r sin t. So you need to decide, are you going to make x r sin t or r cos t, and then the other one that, or whatever, y and z and so forth. But you need to work with that. If you don't see a circle, then just make perhaps xt, or you can make yt, or you can make zt. But just make something t and get the rest in terms of that t. And that's basically that. So let's say that we have something here. So we had this thing here, right? So let's just say there was some other curve, x plus 4y minus z equals 2. Just want to see how it doesn't cut. So let's say equals 10. Yeah, like that. So let's say they give these two things to us and they ask us where does these two cut. So you need to tell them that exact curve there. So these two things here. So let me just write it down. Y squared equals x squared plus 4 z squared plus 4. And then the other equation is just x plus 4 y minus z equals 10. Now I don't see a circle, so I'm not going to work with sin and cos. So I'm going to make anything t, and you can decide then what you want to make t. So I'm going to make y. I'm going to make yt, but you don't have to make yt, you can make xt as well. So if I say y is t, then we have the following. T squared equals x squared plus 4 z squared plus 4. And also the other one says x plus 4t minus z equals 10. So I want to get x and z now in terms of t. So x is just z minus 4t plus 10. So now I just need z. So 4z squared is t squared minus x squared minus 4. So z squared is just t squared minus x squared minus 4 divided with 4. You could have said a quarter t squared minus a quarter x squared minus 1. So z alone is the square root, but positive negative, of this part. Which means I could have made z perhaps, because now it will be a bit too long to substitute in this in here and try to get x alone. So I could have perhaps get z alone in this case. Z alone would have been x plus 4t minus 10. So those two things need to be equal to one another. So let's just take the positive part. Then this is equal to this, because the z's must be equal to one another. And it will be quite a long thing now. I don't want to waste a lot of time now, but in the end, you need to square both sides. Then you will have a quarter t squared minus a quarter x squared minus 1. That's equal to this whole thing just squared. That whole thing squared. And then finally, you will sit with x as it's something in terms of t. And then if you have x in terms of t, then you can find z in terms of t, and you have y in terms of t. Then you can just write all of those, and then you will be able to find the equation of that intersection. But this one, I just took it randomly. It was a bit long. Let's rather have a look at something that that will work out a bit nicer. All right, so let's take this one for instance. A cone and a normal plane. So just a cone, z equals square root x squared plus y squared, and the plane, z equals 1 plus y. Now I don't see a circle again, so I can make anything t. Let's make y again t. If y is t, then z is 1 plus t. So z is 1 plus t, And now I need x. So it's x squared plus y, which is t, so it's t squared. Square both sides. So I have 1 plus t squared is equal to x squared plus t squared. So 1 plus 2t plus t squared is x squared plus t squared. Those two can cancel quite nicely. And we have x as the square root of 1 plus 2t. So the curve at the end is then positive negative square root 1 plus 2t. So you need to write out both. Y is just t and z is 1 plus t. That one was a bit easier, a bit quicker than that other one I tried to do at 10. And that will then be the curve of intersection. And to show that, we can quickly see if I have z equals square root of x squared plus y squared. There's that. And the plane z equals 1 plus y. There's that plane. And where they cut is if x is square root 1 plus 2t and t and 1 plus t. So that's that one part, as you guys can see. And then the other one is just the negative part for the x. There we have it. So those two combined is then the one of intersection. And if there were a circle involved, if you can clearly see a circle, then remember to use sin and cos. R sin, R cos, and do the exact same thing. All right, any questions regarding 13.1? Like I said, I try to go through at least one question at each section so that we can do everything in the end up until 14.8. So please, as you're going through the work, let me know if you have any questions, because I think 10 hours will be not enough to cover all the different types of questions. So that's why you should do it, perhaps go through it on your own, and then if you have any questions, please ask. Right, let's have a look now at 13.2. 13.2 is all about the derivatives. So all that's stated there is now we have some sort of space curve, right? Something, something, something. We can find the derivative. We just get that one's derivative, that one's derivative, that one's derivative. Or we can even find the integral. We just get that one's the integral, that one's integral, that one's integral. And that's about that. But the type of question that I usually ask here is you need to find the tangent line. Then that combines chapter 12.5 and this chapter 13.2. So then it's only one question that they ask, but they already covered chapter 12.5 and 13.2. Then they don't have to set up another question just for a separate question just for 12.5 or just for 13.2. All right, so they can ask something like this. They say, here's some sort of curve. X is t cos t, y is t, and z is t sin t. Then you need to find the equation of the tangent line exactly on that point. So let's just see what they actually ask visually. What they ask is the following. Let me just delete these stuff. There's some sort of curve, t cos t, t and t sin t. However that graph looks like. Quite a nice graph. But at a certain point, negative pi, pi, and 0. There. We need to find the tangent line. So we need to be able to do this at that point and that curve. Doesn't want to click. I want a tangent line. Let me just see tangents. Okay, doesn't want to click. But in any case, we will be able to find the line that's tangent exactly to the curve at that point. So we are technically back to 12.5. For any tangent, any line in the 3D space, we need a point and the direction. Luckily, we do have a point. The point is negative pi, pi, and 0. So that is fixed. We have that. But we also need the direction. And the direction is the first derivative. So R is given as t cos t, t, and t sin t. So the first derivative is the product rule. So it's cos t minus t sin t. That's just for the x. Then 1. And then this is also the product rule. So it's sin t plus t cos t. So the first derivative, or the direction, in the point negative pi, pi, and 0 is an equal to cos of pi, or cos of negative pi is the same as cos of pi, and cos of pi is just negative 1 minus negative pi. Oh, we need to find first the t. So that is just the point. So the problem is it's in the point negative pi, pi, and 0. So we need to figure out what should the t be, because I can't substitute in this. I need to substitute in a t value. What should the t be so that this is equal to that, this is equal to that, and this is equal to that? Now, the easiest way in this specific case is just to look at the y value. T must be y. T must be pi. T must be pi. And let's just see why. If t is pi, we have pi times cos of pi, which is negative 1, which is indeed negative pi. Here will be pi, and here will be pi times 0. So it is 0. So we know at least it will happen or will occur. That point will occur when t is pi. All right, so this means if I want the first derivative in the point pi, it will be cos of pi, which is negative 1, minus pi times sin of pi, which is 0. 1, then 0 plus pi. So the direction then is negative 1, 1, and pi. So finally, that tangent line will be, I'm just going to call it something else. I'm just going to say PT will be the point plus t times the direction. And then it will be negative t minus pi, t plus pi, and pi t. And that's then that. That's all we needed to do. Now, let's just see how it looks like. Because if it's obviously true, then the following needs to be a tangent line. Negative t minus pi, t plus pi, and pi times t. Doesn't seem so. Somewhere I made a mistake. Did I write it out correctly here? Negative t minus pi, t plus pi, and then just pi t. Can you guys see where I made a mistake perhaps? The first derivative is cos t and then t negative sin t. That's 1. That's sin t plus that. T must be pi. So if I substitute in pi, that is negative 1. This is 0. This is 1. This is 0. This is, oh, cos of pi is negative. So that should have been negative. So that is just negative. So it's negative pi. See if you agree with me now. So if I make that one just negative, you can see indeed that is a tangent line to that point. So all that you need to do here is just get the derivative. Make sure you know what your t is, very important. And then you get your derivative, which is your direction of your line. And then just say the point plus t times that. Does that make sense to everybody? Any questions from your side? Nothing. All right, so that is about that for chapter 12.3. Let's start now with chapter 14.1. 14.1 is all about the functions of several variables. So it's basically just to tell you that now we will have curves that might look like this. So we don't just have 2D stuff, it's now 3D. So for that, what they can ask here is just to get the domain. They can ask you to sketch the domain of a certain function. And then they can also ask level curves or contour lines, but that's the same as chapter 12.5 after 12.6, where you just make something k, usually your z, and just get the rest in terms of that. But let's have a look at the question where they ask, we need to get the domain and perhaps sketch the domain. Let's look at something like this, for instance. So the question will just be, what is the domain, and sketch it. So here's a certain function, which is square root of x squared plus y squared minus 4. Now, then you need to have a look. You're not allowed to divide with a 0, and you're also not allowed to have a negative under a square root. So all I know here is x squared plus y squared minus 4 should be greater than 0. Actually, greater or equal than 0. So x squared plus y squared must be greater or equal than 4. So it's just everything, let's say, outside of that. It can be 5, it can be 6, and stuff like that. So if I need to sketch the domain, and I'll show that now, x, y, then it will be a circle, negative 2, 2, 2, and 2, because that's the radius. And I have it as not a dotted line, but a solid line, because it can be included. If this was underneath something, let's say 1 over that, then I wouldn't have included that 4, because it can't be 0. But in this case, it can be 0. So everything greater than that means it's everything outside of this circle. So this will be my domain. And we can check whether that is correct. If I were to draw this, square root x squared plus y squared minus 4, we can see that looking from above, the shadow it casts is everything except within that circle, which is exactly this, which is that part. And there we have it. Does it make sense? I hope it makes sense. Any questions? So that is the type of questions that I can ask there. Now the next part is the limits and continuity. From here on, they can ask really a lot of questions. And you will see if you go through past papers and so, sometimes even just, let's say for the chain rule, they can ask 8 marks or 18 marks just of the chain rule. And then for limits, they can easily ask 15 marks just for the chain rule and so forth. So there's a lot of marks that they can, not one question, but a few questions. Right, so let's have a look at the limits and continuity. So the biggest idea here, especially if they ask you to prove that a limit does not exist, is you need to find at least 2 routes or 2 paths that the limit is different. So if you choose one curve, let's say one curve 1, and you found that the limit and everything was equal to 1, but another curve, that limit of something equals to 2, for instance, then you know the limit does not exist. Now the problem might be, okay, but how do I know which curve to take? Well, you can always use your x-axis if you want to, and your y-axis if you want to, if it is at 0, 0, right? So remember, you are going towards the point that they are interested in. So if you need to go to 0, 0, you can walk along the x-axis, or you can walk along the y-axis. Or, better than that, you say, well, I'm going to walk in any direction in a straight line. So I'm going to walk in any y equals mx. Because y equals mx is just a straight line going through that point. If that still doesn't work, and you don't find 2 different values, then go and have a look at your expression, the denominator of your expression. Go and have a look at that and see what is the relationship between your x and your y. What is the relationship between them? Then try to follow that curve. What do I mean with that? Let's say there stood x to the power of 3 plus 2 y to the power of 2. Then you can say, wait a minute, if x to the power of 3 is perhaps equal to 2 y to the power of 2, then x alone is just 2y to the power of 2 to the power of third. So I'm going to follow that curve. Then you follow that curve. And maybe that curve is a weird curve that goes like this. And if you also go to 0, 0, then maybe that answer is something else, like 6 or something else. Now, just be very careful when you're going to consider using mx. That's only when you're going to 0. So if you are going to something else, another point, let's say you are going to the point 7, 3. You're going to 7, 3.
then you could have walked the normal x equals 7 line, or perhaps the y equals 3 line. You could have walked that. It won't work if you walk along the x-axis, because if you're walking along the x-axis, you won't get to that point. It won't work if you're going along the y-axis, because you won't get to that point. So you need to walk in these two paths. Or if you want to generalize it, you can say I'm going to walk in any straight line from there. So those equations will then be y minus, in this case, y minus 3 equals mx minus 7. Then you walk along that and see where you get. All right, so let's have a look at the question or two when they ask you. Any questions before we do some questions or some problems? No questions. All right, so let's have a look at the question or two when they ask, we need to find whether the limit does not, they will perhaps tell you, prove that the limit does not exist, or show that the limit does not exist. So it's not necessary to do it with the delta epsilon method, although that is also something that they can ask. But now it's just show that the limit doesn't exist. So let's see, I just want to get one here. All right, so let's look at this one here. It is the limit as xy approaches 0, 0 of x squared sin 4y over 3x to the power of 4 plus y squared. Now, luckily I go to 0, 0. So instead of saying I'm going to walk along the x-axis and the y-axis, I want to quickly get to an answer. So I'm rather going to make use of any straight line. So I'm going to say I'm going to walk, my first curve will be just to walk along the y equals mx line. So this means I have the limit as x and mx approaches 0, 0. And then if I substitute that in, I have x squared sin 4mx over 3x to the power of 4 plus m squared x to the power of 2. So I have this. And then I can just factorize the x squared. And that can cancel. Well, before I do that, I know about my other identity from first year, about when I have sin of an angle divided with the same angle. So those two things can cancel. And now I'm going to just do the following. Sin 4mx and 3x squared plus m squared. I'm going to put a 4mx here. but then I need to put a 4mx on top as well. I'm doing it in such a way. Why? Because I know this value here will then be 1. That will just be 1 based on my first year maths. So if that is 1, if I approach to 0, then in the end, I can make all my x's 0. Then I will have 0 over m squared. So this answer is then just 0. It doesn't contradict other mathematical identities or properties. So I'm allowed to have 0 divided with a number. So that answer is then just 0. So that means if I walk any straight line, I will end up at 0. But that's not to say the limit does exist, especially if they ask you to show that it does not exist. So let's see if we can try to find another curve. Now I already took all of the straight lines that I can think of. That's why I approached y equals mx. So for another curve, I'm going to look at my denominator, the relationship between my denominator, which x must be to y squared. So that means just y must be to x squared. So I'm going to use y equals x squared. I'm going to go along that route. So if I take the limit as x squared goes to 0, 0, I will have x squared sin 4x squared 3x to the power of 4 plus x to the power of 4. And I can take out x squared here, and then I have 4x squared, and you'll see now why I'm doing it like that. And x squared here and sin 4x squared. I'm doing it in such a way because, again, this angle here and this value here is the same. So I know that answer will be 1, and this also is exactly 1. So this answer is then just 1. So I found 2 different curves with 2 different values. And that means the limit does not exist. So you can just say this limit does not exist. And the reason why it does not exist is because we have 2 different roots with 2 different values. Now I would just like to show you why those values, or how does those 2 values that we got make sense. So the curve was x squared times sin of 4y divided with 3x to the power of 4 plus y to the power of 2. So it's a weird graph, but let me just zoom in. We needed to go to the point of 0, 0. So looking from above, I need to go to that 0, 0. If I were to walk y equals mx, then as we can see here, it doesn't matter what my m is, I will always end up at that 0 position. Look at when I try to go to 0 there. All of these paths will lead to 0. So that wouldn't have worked to prove that it doesn't exist. What would have worked, as we saw, is to approach the line y equals x squared. So if I were to walk that line, then we can see, I don't think it's going to pick it up, but you can see if I were to walk y equals x squared,
then it's just this, I'm walking exactly on this hill or on this mountain there. Then I will get to 1. If I zoom in here, this answer will eventually get to 1. All right. So that's when it comes to the limit stuff. Again, there's plenty of questions that we can ask. But for now, I think that one will do. All right. All right. So, any questions regarding the limits and continuity? All right. Let's get into the next one, which is the partial derivatives. The partial derivatives, and here is where see there's a question. You can do the squeeze theorem, but it's better to try and stay away from it because it's always better to not use it, especially with 3D stuff. Because remember what the squeeze theorem states? The squeeze theorem is if you have a certain function and you have another function, and we know there's a function between them, like this. Then we can, and this is 2D, right? Now, how are you going to prove that in 3D? Then you need to limit it in a certain direction and so on. So it's a bit more, it's much more trickier to do the squeeze theorem in 3D because you need to work in both directions. You can't just look at one direction, which is typically like this case. So it just comes down to this, just find 2 different paths. Makes sense. Just want to see if there's. They can ask the whole epsilon delta stuff, but it takes long. But there was, so sometimes they don't do it, other times they do. Let's just see, we can have a look at that. Here is one where they actually ask you for 5 marks. You need to prove, so let's look at delta epsilon 1. You need to prove that this following limit does exist, and not just does exist, but is equal to a certain value. We need to prove that this is 0. So just go and have a look at your nice sentence that you need to write, but you say something, just exactly what's in the textbook. Let me just show you. At 14.2. That theorem, let me just get to it. Oh, where am I now? Yeah. This definition 1. You just write that out as these. And you say, all right, so for every number epsilon greater than 0, there is a corresponding number delta greater than 0 such that. So that's what I mean with what. You are writing that down. So in the end, we need to prove, or we need to use this. In this case, it will be x minus 0 squared plus y minus 0 squared. That must be smaller than delta. Then what should be true? 3x squared y squared divided with 2x squared plus y squared minus L, which is just 0. That must be smaller than epsilon. Exactly what's standing here. So now what we do is we use whatever they gave us, just like in first year. We use this to get some sort of relationship between this and this. Why? Because I want to know what I should select as my epsilon. Maybe epsilon is just delta. Maybe it's 3 times delta. Maybe it's 20 times delta. Maybe it's a fifth delta. We don't know. We need to get that. And then we go back again. So it seems as if we are doing the same thing over and over. So starting from that, and there's not a fixed method that you need to use. You just need to be creative and use some logic. So we know that value is definitely greater or smaller or equal than just normal square root 3 over x squared plus y squared. Why can I say that? Well, this numbers, if I just take it away, I will be smaller. And if I take that also away, if I just take the square root, that's what I've done here basically, the square root. If I take the square root, let's say that falls away, and then this number here would have increased this, but because those values are not there, it is definitely smaller. And again, like I said, I want to get as quickly as possible from this to something like that. So that's why I just introduced the square root stuff. But that value is definitely smaller or equal than square root 3 times square root x squared plus y squared. It must be smaller because here I am dividing, here I am multiplying. But wait a minute, this part here is like delta. So I'm going to say this is the same as, let's say, square root 3 delta. I can say smaller. Smaller or equal at least. And now I know what to choose. You could have also started from this blue part, just to show you. If you perhaps started with the blue part, you could have said, well, I know x squared is definitely smaller or equal than 2x squared plus y squared. Why? Because y squared is always greater than 0. So if I divide now with a 2x squared plus y squared throughout, I have the following. X squared divided with 2x squared plus y squared, that's smaller or equal than 1. Now I multiply with the square root 3. So I have square root 3x squared divided with 2x squared plus y squared, that's smaller or equal than square root 3. Now I'm dividing with square root 2x squared plus y squared. Then I have square root 3x squared divided with that, and those two multiplied with one another will then just be that part. That must be smaller than square root 3 over square root 2x squared plus y squared. Which I know this must be smaller. This must be smaller or equal than square root 3 over just that part. So I take out the 2, which must be smaller than square root 3 times square root x squared plus y squared. So in the end, I basically have this. I have this part here. That is smaller than square root 3 square root x squared plus y squared, which was that delta. So therefore, I choose epsilon
to be equal to square root 3 delta, meaning delta is just epsilon over square root 3. And then if I use this orange part, I know this is square root 3 of delta, and delta is epsilon over square root 3, which this is equal to epsilon. So in the end, I've actually proven this part here. I've proved that. And then you just write that whole sentence about, therefore, this limit does exist and so forth. And this limit is equal to 0. So like I said, it's not nice work. You start off with one thing, see if you can get the relationship between that and this blue part, and then just write everything out again and say, therefore, the limit does exist, or that is the limit. All right, but let's carry on. Let's carry on to partial derivatives. So partial derivatives is just here to, you need to know, okay, I'm going to divide it. I'm going to derive first in terms of x and then in terms of y and stuff like that. So there's not really a lot of questions that they can ask here, but what they do like to ask here is the Clairaut's theorem. So just make sure you know that proof, because it's a lot of points, 10 marks at least, or yeah, usually it's 10 marks. So make sure you know how to do the proof, and for that matter, all the proofs you need to know how to do. So for this 14.3, I'm not gonna do a lot of questions here, because it's just finding the derivative in terms of x and finding the derivative in terms of y and so forth. So I'm gonna go to 14.4, where they ask us for the tangent planes and the linear approximation. Remember, they can also ask for the quadratic approximation. That's also something that they can ask. So let's just see how they can ask this. So, and then the linear approximation is basically the surface, the plane. So they can give you a certain function, and let's just find the linearization. Just want to see if this one will work. So here's a certain function that they give us. F of xy is equal to 1 plus x ln xy minus 5. And then they will ask you to find the linear approximation at a certain point. So in this case, at the point 2, 3, we need to find the linear approximation, which is the same as the tangent line. Just make sure you write the right one down. Okay, so for linear approximation, we have the function in that point plus the first derivative in terms of x in that point times x minus 2 plus the partial derivative in terms of y in that point times y minus 3. So first of all, let's just go and calculate what is the first derivative in terms of x and in terms of y. In terms of x, it's now the product rule. So we need to get that. So it's just ln xy minus 5 plus xy minus 5 at the bottom and multiply it with x times y, so it's xy. And for the y, we have, if we get the derivative, in terms of y, it is just x times x, so it's x squared divided with xy minus 5. And just mention that your xy minus 5 must be greater than 0. So therefore, it is the point in 2, 3. So if you substitute in 2, 3 in this equation, you have 1 plus 2 times ln of 6 minus 1, which is just 0. So that part will just be 0. So it's just 1. Plus, if I substitute in 2, 3 here, I will get 0. And here I will get 6 over 1. So it's just 6 of x minus 2. Plus the partial derivative of this one in the point 2, 3. So I have, if I substitute in 2, I get 4 over 1. So it will just be 4 multiplied with y minus 3. So the linearization would have been then, or would be, 1 plus 6x minus 12 plus 4y minus 12, which is 6x plus 4y minus 23. And that would have been the same as the tangent plane. If you just say z equals to that. And just to show what we've done now, so that it makes visually sense as well, if we have a function z equals 1 plus x times ln of xy minus 5, that is just some sort of graph at the point 2, 3, and when a is also at 2 and 3. So it's at the point 1 there. There exactly. The question is, what is the linear approximation? Basically the tangent plane, and it is z equals 6x plus 4y minus 23. But can't there be something that wraps better around that point? And the answer is yes, if they ask us for the quadratic approximation. The quadratic approximation is now just the second order Taylor polynomial. So it is the linear approximation that we already got, plus half of xx in the point 2, 3 times x minus 2 squared, because quadratic needs a square, plus xy, according to Clairaut's rule, is the same thing. So that's why it's half plus half, so it's just 1, of x minus 2 times y minus 3, plus half of x of yy in the point 2, 3, and that then is just y minus 3 squared. So we have 6x plus 4y minus 23 plus a half of, and let's just see what the partial derivative in terms of xx is. It will be quite a lengthy one. So it will be y over xy minus 5 plus then the quotient rule y times xy minus 5 minus xy times y divided with xy minus 5 squared. And for xy, you do the same thing. This one will take now too long. I don't want to waste time. But then you will find these values. And then let's say it's 4, 3, and 2. And then just multiply it with those values there. Then you write it out. So you will have something squared. And that then is the quadratic approximation. So it will just wrap around that point much better than just a straight line. All right. So the tangent
plane and the linearization is basically the same thing. Just make sure you write the right one, because they can deduct marks if you don't write the right one, although the answer will be basically the same thing. All right, let's get on to the next chapter now. Any questions from your side before we carry on? So for the chain rule, remember, for the chain rule, there is also a proof that you need to know, and they can ask that proof. They did in the past semester tests, if I'm not mistaken. So make sure you know that the chain rule. Like I said, just make sure you know all of your proofs that you need to know. But for case one, usually they ask case one for the proof. But we know that if we want to get the derivative of zt, then basically it's zt, and then those x's, those y's, because we have it in terms of, we have x in terms of t and we have y in terms of t, but they want z in terms of t. So yes, you can go and substitute in everything so that you just have one equation in terms of t, but that's not what they want you to do. So you won't get your marks if you do that. And for case two is then everything like case one basically is just now partial. So everything is partial. Where that top one is also partial, that beginning, but that end part is just a d. And then finally, you can also find the whole implicit part, implicit differentiation. You can use this where f is just everything equated to 0. So you you have an expression and then you just get everything on one side, and that is your f. So they can ask a question. Let's say they ask a question like this, and I say, this is now, and they just want in terms of y. That's what they want. Let me just write it out. So yz plus x ln y equals 2z squared. So just take everything to one side. So that will be my great F is yz plus x ln y minus z squared, that's equal to 0. So I know partial z over partial y is the same as negative the f in terms of y divided with the f in terms of z. It's just a quick way of doing this. So the f in terms of y is z plus x over y, and the portion in terms of z is just y minus 2z. And then that is the answer. So just make sure what they're asking for and write down what they're asking for. If they ask for the partial z in terms of x, then obviously you need to do it in terms of x. Let's have a look at another question. So we need to find dw over dt. And here is the equation that what they say here. That is what w is, and that is what t is, and y is, and z is. So we know dw over dt is partial dd plus partial dd, and there will be a few things, plus partial dd. I want wt. But what do I have? I have x, I have y, and I have z.
So W in terms of X will just be e to the power of Y over Z times X in terms of T, which is just 2T. Then W in terms of Y is then just X e to the power of Y over Z times 1 over Z, so it's X over Z. And then Y in terms of T, which is just -1. Plus then we have here X e to the power of Y over Z. And remember, basically what stood there in the beginning was e to the power of X e to the power of Y times Z to the power of -1. So I need to multiply with the derivative of Z, which is -Y. Let me write it here. -Y Z to the power of -2. And that all multiplied with Z's derivative in terms of T, which is just 2. Then hereafter, you just need to go and substitute in your Y with T minus 1, your Z with 1 plus 2T, and so on. So all of your, then you just go and substitute it back in. Because they wanted it in the end in terms of T. So just go and substitute in all of your X's with that value, all of your Y's with that value, and all of your Z with that value. All right. So let's get to the direction derivative and the gradient vector. Direction derivative and the gradient vector. So again, just in short, what is the direction derivative and what is the gradient vector? A gradient vector, if you're standing on any place on a mountain or whatever, and you are planting a pole perpendicular to your surface, the ground surface where you are standing on, then the shadow that's being cast on the ground from that pole, looking from above, that shadow, let's say that shadow look like this. That then is your gradient vector, that direction. So the gradient vector is always the most difficult route to take. That's why the direction derivative of a certain function at a certain point is just the gradient vector dot product the direction they say you need to take. But if that direction is the same as that direction, which means it's a dot product, which means it's cos of 0 or cos of 180 perhaps if it's just opposite, or cos of 360, then it will be the maximum. So they usually ask you, then they ask you what should theta be, or in what direction should the maximum be? Then you say it must be in the same direction as your gradient vector. Why? Because it's a dot product and cos of 0 or cos of 360 is 1. So that's when it's the maximum. So that's the type of questions that they can ask there. So let's just have a look at one or two. Let's say they said the following. Let's say there's some sort of function, and this function is in terms of x and y, and it is x squared e to the power of -y, and then in the point 3, 0, somebody's telling you walk exactly in this direction.
So what is the direction derivative in that point? So we know the direction derivative in the point 30 is just the gradient vector. Let's just first get as an expression. It's the gradient vector dot product the unit vector. The gradient vector will be 2x e to the power of negative y, and then negative x squared e to the power of negative y. Dot product, that 3, 4. So the direction derivative in the point 30. Now if I substitute in 30, I will get 6 and then negative 9. Just double check me. And then it's 18 minus 36. So this answer is just negative 18, which is quite significant, but it's not to say it's the maximum. The maximum would have been if we were to walk in that direction, and I'll show that in a moment again. So just to illustrate what we've done here, we have z equals x to the power of 2 times e to the power of negative y. So there's some sort of curve, and they want to know when you were being dropped at the position 30, and then when a is 30. So there's a point there, A. And now, looking from above, somebody's telling you, walk in the direction of 3, 4. So walk in this direction. Just want to get something here. There. So looking from above, you're standing there at position A, right there. And somebody's just telling you walk in this direction of this line. So if you go according to that line, you will be there. And that gradient exactly there is negative 18. It depends on what direction you're looking at. So 18 or negative 18, which is quite significant. But is that the most difficult route to take? Well, if we can check, if we can see it just visually, just take that away. We can see if I'm there exactly at that point A, it might not be the most difficult. It is steep, but I think if we were to go a bit more straight like this, it would have been steeper. And that is perhaps if they ask you, what is the maximum gradient vector? So the maximum gradient vector is now, this is the gradient vector at that point. But if I want to get the maximum, it is just the maximum in the point 2, 3, which is then just square root 6 squared plus 9 squared, which is the square root of 36 plus 81. So it is 10.816. That is the maximum. Where will that occur? So that's just the maximum of the gradient of the rate of change. Where will that occur? It will occur in that direction. What is that direction? It's the direction 6, negative 9. If they ask you for the unit vector, then you need to say 6 divided with that value there is 3 square root 13. So divide with 3 square root 13, and then just negative 9 divided with 3 square root 13. So that is then the direction which the maximum will occur. And just to show you that, if we were to walk in the 6, negative 9 direction, 6, -9. That's now that E. As you guys can see here, so if I were to walk rather in this direction, then that would have been a maximum. That is a maximum. And we can calculate what is that maximum, not the maximum of the gradient vector, but rather the maximum of the direction derivative, which is just 6, -9 multiplied with that direction, dot product that direction, which is also 6, -9. So it's gen 36 and then just plus 81. So it's quite a lot. All right, so that's direction derivative and gradient vector. Let's get to the maximum and minimum values. I'm almost certain that they will ask questions like this. And then we will also discuss how they usually ask questions like that. Especially in a semester test, because there's not a lot of time left, right? So you'll see this one is 6 marks. And they will ask questions like this. Let me just post it and I'll show you. Just want to take a nice. So typically how they usually ask it in a semester test, hopefully it's the same tomorrow. They give you a function, then they say you need to complete this table. So you need to find f of x, xx, f in terms of x, f in terms of xx, and so forth, so that you can discuss the critical points. So remember, for maximum minimum, it's some sort of curve, 3D curve. We need to find the points where we are interested in. So those critical points. And the critical points occur when this direction and that direction's tangent line is equal to 0. So you need to find in terms of y and x, and you need to equate it to 0. Solve it simultaneously so that you can find those positions. And in those positions, you need to calculate the d value. And then you need to make use of that little table thingy that tells you exactly if d is greater than 0 or if d is smaller than 0 and everything like that. The second derivative test. Then it will tell you, is it a local minimum or local maximum and so forth. So let's have a look at this question here that was in this specific paper. The one that I just showed you earlier. So we have here f of xy, that's equal to 12x squared plus y to the power of 3 minus 12xy. So we need to find the partial derivative in terms of x, which is 24x minus 12y. And I'm going to equate it to 0. Then the partial derivative in terms of y, which is 3y squared minus 12x. And that must also be equal to 0. So somehow I need to find values for these two things. So that first one just states that x is equal to a half y. Substitute that back in this equation here at the bottom. Then we have 3 times a quarter. 3y squared minus 6y. That's equal to 0. So y squared minus 2y is equal to 0. So y minus 2 is equal to 0. So y is equal to 0 or y equals 2. So my critical points is 0 for the y
or 2 for the y. What is the x then? Well, if y is 0, x is 0. And if y is 2, x is 1. So there's only 2 critical points. But now I need to have a look at the d value. But before I get the d value, I first need to get xx. So xx is just 24. Xy is just negative 12. And yy is just 6y. So the d is 24 times 6y minus negative 12 squared. Which is 144 y minus 144. So the d value in the position 0, 0 will just be negative 144, which is smaller than 0. And the xx in that position, or in that point, remains 24, which is greater than 0. But because the d is smaller than 0, I know this will be a saddle point. A saddle point. But the d here will be 144, which is greater than 0, if you're substituting y as 2. And xx in this case is still 24, so it's greater than 0. So therefore it's a local minimum. A local minimum. All right, so just to show you this, that we know it's right. Oops. We have here z equals 12x squared plus y to the power of 3 minus 12xy. And we can see there's 2 things that happen. Looking from above, it will happen at the position 0, 0 and at the position 1, 2. And at 1, 2, we can see it's a local minimum, exactly there. If I just take this bit down, that position there. And at 0, 0, it's just a saddle point, as we can see. And that's exactly what the math also shows us. So that is just a saddle point. All right. So I think, or I hope, they will also ask it in such a manner where they give you some sort of table, and then at least you can fill it in. Otherwise, it really takes a bit of time, and I know time is not on your side during the test, during any MTHS test. All right, let's get to the Lagrange stuff, because I'm sure they will ask questions like with that also. So the whole idea behind Lagrange is you will be given some sort of, and then they have a method of Lagrange multiples that they give us. Let me just show that. So you will be given some sort of function. You need to figure out what is that function that you are interested in. Usually it is the thing that they ask, like the maximum volume or the minimum speed or the maximum surface area or stuff like that. That usually you make your f.
Then your constraint is the part where they perhaps say you're not allowed to use so many paint or so many length of wire or whatever the case might be. That is part that's equal to a constant. Then you take the gradient vector of f equated to the lambda multiplied with the gradient vector of g and try to solve that. If you get some sort of expression like x equals y and something like that, go substitute it back in that equation so that you can find the values. And as soon as you have the values, then you know where the maximum or the minimum will occur and so on. So let's just have a look at maybe a few questions where they ask for the Lagrange, and they can ask you to use Lagrange, but also it's also possible to not ask for Lagrange, but I think they will tell you, listen here, we want you to use Lagrange. So let's look at a few questions. And sometimes they will ask you in terms of a sentence or a scenario, and then you need to find it yourself. All right, let's have a look at this one here. They say here, just want to take this away. They say here, this plane, and let's just draw that plane. I just want to visually show that to you. There's some sort of plane, 4x minus 3y plus 8z, that's equal to 5. So there's that plane. And they say it intersects the cone z squared, that's equal to x squared plus y squared. And we can see it cuts there somewhere. There. Now, exactly where they cut, they ask us now, use Lagrange multiples to find the highest and lowest points on this ellipse. Now, visually, we can see the highest point will be there and the lowest point will be there. But let's see what we can do if we need to make use of Lagrange. Because they said we need to make use of Lagrange. I just want to write everything out here. And then the other part is z squared, that's equal to x squared plus y squared. So the thing that's equal to a number is this one here. So that will be my g. So g of x, you can equate everything to 0 if you want to. But g of x then, g of xy is that 4x minus 3y plus 8z. And this then is my f function. But I need to get everything in terms of z or so. So you can try to get z alone. Just want to see where am I now? That one there. Because we need to find this equation as well in terms of x, y, and z. I can take the square root as well. So z alone is just the square root of x squared plus y squared. So that's then my z.
But that one now will have an extra z part. So this time, I will rather make use of the following. So this question is actually a nice question because we need to make use, or they can perhaps, unfortunately, here will be two constraints. Here will be two constraints because the part that we are interested in is the height. So the part that we are interested in is just what is the height? What is the z? So that's our function. Remember what I said earlier? The function that's the f will be the part that you're interested in. And what are we interested in here? Just to show this again. We are interested in the height. So what is the height? The height is just z. So that is what we're interested in. This is one constraint, and the other one will be then the other constraint. So there will be two constraints this time. So let's make it h. H of x, y, and z is then z squared minus x squared minus y squared. That's equal to 0. Now, I don't think they will ask you to solve it, but they can ask you to set up the equation. So we know gradient vector of f must be lambda gradient vector of g plus lambda, not lambda, but let's say me, gradient vector of h. And then the gradient vector of f is 0, 0, 1. Lambda of the gradient vector of g is then just 4, negative 3, and 8. Plus me, the gradient vector of h is negative 2x, negative 2y, and 2z. And now you need to just solve, if we look at the x part, we need to solve the following. 0 equals 4 lambda minus 2x me. For the y part, we need to solve 0 equals negative 3 lambda minus 2y me. And for the z part, we need to solve 1 equals 8 lambda plus 2 z me. And those are the equations that we need to solve. So that together with the two constraints, it's, like I said, it's quite a lengthy, especially if it's two constraints. That's why usually they will only ask you, if there's two constraints, just set up the equations like we've just done. Because to solve this now is really long. So let's rather have a look. Just want to see this question. Where does the vector 0, 0 comes from? Is this equation's the gradient vector, f's gradient vector. It's just z, so it's 0, 0, then 1. Fine with that. All right. I just want to find one that's actually just one constraint. No, I can't seem to find one now, but let's just do one where they give us the constraint. And we just at least do one like that. So here they give us the function and they also give us the constraint. So f of x, y is equal to x, y. We don't know what that implies. Maybe it's the surface area, maybe the distance and everything like that. We don't know. But that's just the function that we're interested in. And then g of x, y is 4x squared plus y squared. You can say minus 8 that's equal to 0 or equals to 8. it will in the end just be the constant will fall away. So we need to solve the gradient vector of f equals to, and there's only one constraint, so it's just the gradient vector of g. So we have y x, that's equal to lambda 8x 2y. So we need to solve that y equals 8x lambda and x equals 2y lambda. So we need to solve this simultaneously. Let's multiply this first one with x. Then we have xy equals 8x squared lambda. And I'm going to multiply the bottom one with y. Then I have xy is equal to 2y squared lambda. Then I know these two things must be equal to one another. So 8x squared lambda must be equal to 2y squared lambda. So the lambdas can cancel out. And I have here 4x squared equals y squared. Now to get some sort of numbers, I can equate it in this equation here. So I have 4x squared plus y squared, which is 4x squared as well, minus 8 equals 0. So 8x squared equals 8. So x equals positive negative 1. Which means the points that I'm interested in is either negative 1 and something, or 1 and something. What is that something? Well, here we have, if x is 1, then y squared, there will actually be more than, there will be 4 points. Why? Because if x is negative 1, then we will have 4 equals y squared. So y might be negative 2 or positive 2. And if x is 1, y, then we have 4 equals y squared, so it's also negative 2 or positive 2. So there's 4 points. Now for the maximum or the minimum, just go and substitute in the points in your function that you're interested in. Remember, we are interested in this function. So this point will result in 2. This one will result in negative 2. This one in negative 2 and this one in 2. So the maximum value is then 2 and the minimum value is then negative 2. Everybody good? Right, so we've run through everything from chapter 12.5 until 14.8 in 2 hours. And obviously we didn't cover everything, every different type of question, but please go through the work. And if you have any questions, please ask if there's some uncertainty or unclearness or so. All right, you must have a wonderful day further, and good luck with the preparation.